Welcome everybody. Today we are talking about elements and compounds. Chemistry, ICSE, class 7. Chemistry chapter 1, ICSE class 7 pattern, elements and compounds. What are elements, what are compounds? We know that in our environment, we on a daily basis come across lots of biotic and abiotic things. The natural things, the living beings. Now, what we see in nature, the many materials, the many substances can be classified further into depending upon their characteristics in different forms. For example, the state of matter we call it as solid, liquid and gas. So likewise, matter can be classified as elements, compound and mixtures. Now what are these classifications? Elements, compounds and mixtures we will see in detail in this class. Now there are lots of substances that we get from nature, from the rocks, from the soil, from the air, from the water. So these are different materials that we get, different substances that we get, and these have specific properties or specific characteristics. Now, element is something that cannot be further split into further simpler substance. A substance that cannot be further split into a simpler substance is called element. For example, hydrogen is an element, carbon is an element, copper is an element, which cannot be further split into for a simpler substance. It is called element. There are 114 plus elements that we know as on today. Substances that contain atoms of the same kind. That is why it cannot be split further. If there are atoms of different kind, it can be split into atom A and atom B. Elements cannot be split further into simpler substance. Compounds. Compounds are those that can be split into two or more substances by chemical means. Compounds are those that can be split into two or more substances by chemical means. For example, water is called H2O. That means what? We can split water into H, hydrogen, and O, oxygen. So water is a compound, hydrogen and oxygen are the further simpler elements, and because of this, water is called a compound. Common salt is sodium chloride, Na and Cl. The symbol for sodium is Na, symbol for chloride is Cl. It contains atoms of different kind. Sodium atom and chloride atom together is what is called sodium chloride, which is we normally call as common salt. Now, the amount of different elements in a compound is always fixed. In sodium chloride, there will be one sodium and one chloride. In water, there will be two hydrogen and one oxygen. So, the amounts of different elements in a given compound is always fixed. Only then it is called compound. If this amount of different element in a compound is not always fixed, then it is not called a compound. It is called a mixture. We will see in detail later. Now, 8 gram of oxygen and 1 gram of hydrogen makes 9 gram of water. That is why we say the amount, the proportion of the different elements in a compound is always fixed. 8 gram of oxygen and 1 gram of hydrogen makes 9 gram of water. The elements combine themselves in a definite proportion to form compound. Elements are the simpler substances, the basic substances which has only one kind of atom and which cannot be divided further. This is element. These elements combine themselves, combine together in a definite proportion. This is 8 plus 1, 8 is to 1 proportion to form a compound. Now, what is special about compounds? Compounds have specific properties and their properties mostly are different from the properties of the constituent elements. The properties of the compounds are different from the properties of the constituent elements. That means what? The property of hydrogen is different, the property of oxygen is different, and property of H2O water is different from hydrogen or oxygen. The compounds are different from the constituent elements in their appearance. Hydrogen and oxygen are in gaseous form, water is in liquid form. The compounds differ from their elements in the appearance. Ferrous sulfate crystals are green, but ferro, that is iron, is grey and metallic. Copper sulfate crystal is blue, but copper is a metal and it is red. So it is not a crystal. Copper is not a crystal, copper is not blue, but copper sulfate is blue. So, the compounds differ from the constituent elements in the way they look, in their appearance, in their properties, in their characteristics, metallic versus crystal, grey versus green, etc. So, this ferrosulfate crystals are green, copper sulfate crystals are blue. Now mixture, what is a mixture? Substances that contain one or more elements or compounds is a mixture. Substances that contain one or more elements or compounds is a mixture. So what's the difference? If the elements are in definite proportion, it's a compound, right? And in a mixture, the constituent can be separated by physical or chemical means. In a compound, they can be separated only by chemical means. In a mixture, they can be separated either by physical or chemical means. For example, the dust, the dirt, the small stones, the rice, the husk, the paddy, everything mixed together is a mixture. It can be separated by physical means, by winnowing, etc. Now, composition of mixture is not definite. There is no rule how many stones can be there in a bag of rice. But in water, there can be 8 oxygen and 8 hydrogen and 1 oxygen only. Now, mixture can be separated by filtration, sublimation, distillation, etc. also when they are in liquid form. Air contains elements like oxygen, hydrogen, etc. It is a mixture. Atmosphere is a mixture. It also contains compounds like water vapor and carbon dioxide. So, some elements, some compounds, all put together is called air, which is a mixture. Now, let us look at what are molecules. Now, matter is made up of small particles. Atoms and molecules are the small particles. Now, we have seen what is element. Element is something which cannot be further divided into simpler substance, and they contain atoms of same kind. So, that is this atom. And then we have molecules. Now, let us see in detail what is an atom. Atom is the smallest indivisible part of an element that has all the properties of that element. Atom is the smallest indivisible part of an element that has all properties of an element. Element is something that cannot be split into simpler substances by chemical means, and they contain atoms of the same kind. Atom is the smallest indivisible part of an element that has all the properties of that element. If you divide the atom further, then it will not have all the properties of that element. So the smallest part that has all the properties of that substance is called an atom. Atomos means indivisible. The word comes from this root, atomos, indivisible. That means what? It is the smallest indivisible part. Further division is not possible. If you divide, it will lose the characteristics, the properties of that element. All atoms of an element are alike. All atoms of hydrogen are alike. All atoms of oxygen are alike. But hydrogen atom is different from oxygen atom. Atom of one element is different from atom of another element. Now, all atoms of hydrogen display the characteristics of hydrogen. No atom of hydrogen display the characteristic of oxygen. One atom of hydrogen cannot be changed into one atom of oxygen. One atom cannot be changed to another. All atoms of an element display the characteristic of that element and it cannot be changed into another. Most importantly, atoms can neither be created nor be destroyed by chemical means. Atom is the smallest indivisible part of an element that has all the properties of an element and they cannot be created nor destroyed by chemical means. You cannot create an atom by chemical means nor destroy it. Atoms are represented by symbols. For example, H stands for hydrogen, Ca is calcium, Mg is manganese, Na is sodium, Ag is silver. Now what does this one? Hydrogen, English word H, first letter. Calcium, when one letter cannot be used, they use two letters. So C is carbon, Ca is calcium. Now if two continuous letters, Ma cannot be used, then they use the Latin words Mg, magnesium, sodium, Na, silver, Ig. So they use either the English word or the Latin Greek roots and then they use first two alpha or one and then a unique alpha or a single alphabet whichever is available to uniquely represent that particular element is called the atomic symbol of the element. Atoms are represented by symbols. This is the symbols of the elements. In the previous class, we would have also studied the periodic table where all the elements are arranged in the form of a table depending upon what type of element it is. Now regarding molecules, what is atom, what is molecule? We have seen atom is the smallest indivisible part and the molecule is sometimes atom don't exist singularly. They do not exist independently. They would like to exist together, combined, just like human beings are social animals. We like to live as a family and not as individuals. atoms also sometimes do not exist independently. They combine to form molecules. So group of atom is called molecule. Group of atom is called molecule. Now when we say atoms combine to form molecule, then how do they combine? That is why we have to know about valency. What is valency? Valency is the combining capacity of one element with other elements. Now when we say atoms do not exist independently and they combine together, it is not necessary one hydrogen atom has to combine with another hydrogen atom only. Hydrogen atom can combine with oxygen. So 2 hydrogen plus 1 oxygen will become water. 1 hydrogen plus 1 oxygen OH will become hydroxy. Like that they can become. So how do we know how they become or how they combine together or what is their capacity to come together? That is what is called valency. The combining capacity of one element with other element is called valency. Now what is valency of hydrogen? Valency of hydrogen is 1. All other valency of all other elements are represented as a multiple or in the form of valency of hydrogen. The combining capacity of one element with other element is called valency. Valency of hydrogen is 1. Valency of chlorine is also 1. Valency of zinc is 2. Valency of nitrogen is 3. Valency of carbon is 4. That means what? 1 chlorine will join with any other element. 2 zinc will join with any other element. 3 nitrogens will join with any other element. 4 carbons will join with any other element. This is the combining capacity of this particular element, carbon or nitrogen, with other elements. Valency of other element is the number of hydrogen atom that combine with one atom of that element. So when we say valency of carbon is 4, that means 4 hydrogen atoms can combine with one carbon. When we say valency of zinc is 2, that is 2 is the number of hydrogen atom that combines with one atom of zinc. So valency of hydrogen is 1. Combining capacity of one element with other elements is called valency. Valency of other elements is the number of hydrogen atom that can combine with one atom of element. So when you have a question what is valency, the answer should be valency of other elements is the number of hydrogen atom that can combine with one atom of that element, and valency is the combining capacity of one element with other elements. That is how you answer. So first and third lines you will have to answer. Valency can also be said as the number of hydrogen atoms that one atom of that element displaces in or from a compound. If there is a compound, valency is the number of hydrogen atom that one atom of that element, carbon or chlorine or whatever, displaces from that compound. Now, if the valency is 1, it is called monovalent. If the valency is 2, it is called bivalent. If the valency is 3, it is called trivalent, like that. So, valency of other element is the number of hydrogen atom that can combine with one atom of that element. Valency of hydrogen is 1, and combining capacity of one element with other elements is called valency. So, this is valency. Now we know the valency. What is molecule? Atoms combine to form molecules. How do they combine? Based on the valency. Molecule is the smallest part of an element or a compound that exists independently. Atom is the smallest indivisible part of an element that has all the properties of that element. But atoms need not necessarily exist independently. They combine. So molecule is the smallest part of an element or a compound that exists independently. Molecules of helium, neon, argon, etc. have only one atom of that element. Whenever you write the name of an element, you have to write in capital letters. First letter has to be usually capital. Now, when these are inert gases or minor gases, very little only we have. These inert gases have only one atom of that element. They don't have to combine with something else to remain independently. But atoms of hydrogen, nitrogen, they combine themselves. Atom of hydrogen and nitrogen combine themselves. Combine themselves means what? Hydrogen will join with another hydrogen. Nitrogen will join with another nitrogen. Atoms of two or more elements combine, then they call it as a compound. Compound is two or more elements in a definite proportion. Mixture is two or more elements or compounds in any proportion. Atom, the smallest indivisible part of an element. Molecule is the smallest part of an element that exists independently. It is a combination of atoms because atoms cannot exist independently. These atoms combine together according to their valency. Valency is the combining capacity of an element, where valency of hydrogen is 1 and valency of other elements are the number of hydrogen atoms that combine with one atom of that element. Now, like elements have a formula C for carbon or Ag for silver, molecules also have formulas. Molecule of an element or compound is represented by formula. Formula gives the number of atoms of each element in that compound. For example, H hydrogen means hydrogen is one atom, but in water it is H2O. So H2 is a compound consisting of two hydrogen and one oxygen, H2O. Formula gives the number of atoms of each element in that compound, a number of atoms of each element in that compound. So what do we call it as? We call it as monoatomic, diatomic, triatomic, depends on how many. Ne is 1, nitrogen is diatomic, ozone O3 is triatomic, then we have phosphorus is 4, sulfur is 8. This is number of atoms that form the number of atoms of sulfur that goes into that compound. This is number of atoms of each element into that compound. Now in valency we have seen monovalent, bivalent, trivalent, that is zinc is 2, nitrogen 3 and carbon 4. Here we have monoatomic, diatomic, number of atoms of each element in that compound. Formula is found by transposing the valencies. Transposing the valencies. So we have seen what are the valencies. Zinc is 2, nitrogen 3, carbon 4 is a valency. That means the number of hydrogen atoms that combine with one atom of that element. When you say transposing the valencies, what do we do? If hydrogen and oxygen are combining, valency of oxygen will come to hydrogen, valency of hydrogen will go to oxygen. That is what is called transposing of valencies. So valency of Al is 3, valency of Cl is 1. So Al and Cl, aluminium and chlorine, will combine in a fashion that Al1Cl3. Number of atoms of hydrogen that this will combine with is the valency, right? Number of elements of hydrogen atoms that combine with one atom of that element. So here valency 3 means 3 hydrogen can combine with Al. Valency 1 means 1 hydrogen can combine with Cl. So 3 Cls and 1 Al will form the aluminium chloride. Now valency of sodium is Na1, valency of oxygen is 2. So 2 NAs and 1 O together will form sodium oxide. 2 Na and 1 O will form sodium oxide. Now valency of zinc is 3. Valency of zinc is 2. Valency of zinc is 2. We have seen zinc valency is 2, nitrogen 3, carbon 4. Valency of zinc is 2, sulfur is 2. So it should become actually what? Zn2 and S2. But because both is 2, we write as ZnS. Zinc sulfide is ZnS. Zinc sulfide. This is sodium oxide. Aluminium chloride. This is water. This is how the molecules are formed. One or more element combine together because they cannot exist independently. Molecule is the smallest part of an element or a compound that exists independently. So they combine together like this. Depending upon the valency, the formula is written by transposing the valencies. Formula is written by transposing the valencies. Now, we have a variable valency. Some elements have more than one valency. For example, iron has 2 and 3. This means what? FeCl2 and FeCl3. Why the 2 and 3 is coming near chlorine? Because the valency has to be transposed. So iron has 2 valencies and 3 which are 2 and 3. Copper has 2 valencies 1 and 2. So if you have a copper chloride, you will write this 1 and 2 will come here near the chlorine. Sulfur has 3 valencies 2, 4, 6. Copper has 2, 1 and 2. This has 2, 4, 6, 3 valencies. Iron has 2 valencies which are 2 and 3. So CuCl. CuCl is copper chloride and you write it has 2 valencies, either CuCl or CuCl2. So if it is CuCl2, that means we are using this valency. So how do we write? We write 2 here like this. Copper 2 chloride. That means second valency of copper. Second copper is we are using. Likewise ferrous, if you are using the third one, we write Fe2O3. Why? Valency of oxygen is 2, valency of ferrous is 3. Now when you are using a ferrous ion of third valency, 3 valency, then we write as iron 3 oxide. Iron 3 oxide, we write it is using the valency 3, the combining capacity of 3 is being used here. So these are the variable valencies when you form a molecule. Now atomic world, this is a very interesting area, atomic physics. Atom was thought to be indivisibly smallest unit. We have seen that atom is the indivisible part of an element that has all properties of an element. It was thought to be indivisibly small unit, but later or now we know it is made up of proton, electron, neutron, etc. Who were the father of this invention or discovery? Chadwick, Thomson, Rutherford are the scientists who worked and helped us discover proton, electron, neutron are the constituents of an atom. Chadwick, Thomson, Rutherford are the scientists who worked to discover and tell us proton, electron, neutron are constituents of an atom. Atom is the smallest indivisible part of an element, but then it consists of subatomic fundamental particles. Atom consists of subatomic fundamental particles called proton, electron, neutron. What is electron? Electron is something that carries a negative electrical charge. It has a negligible mass. Negligible mass means what? It is very small in mass and weight. How small? 1000, 2000, 1 by 2000 of the lightest atom. 1840 times lighter. That means what? 1 by 1840. That is 1 by 2000 times of the lightest atom, which is hydrogen. Lightest atom is hydrogen. So this is electron. Negligible mass, lightest atom 1 by 2000 times carries electrical charge. This is one of the constituent of the atom. So what did Chadwick, Thomson, Rutherford find out one more? They found out proton carries positive charge. Electron carries negative charge, proton carries positive charge. The mass is same as that of hydrogen atom. Mass is same as that of a hydrogen atom. Lightest atom is hydrogen. So how much is this mass? 1 AMU. What is AMU? Atomic mass unit. AMU. You cannot measure it in ton, quintal, kilo, gram, etc. Because it is very tiny thing, very small, tiniest particles, an indivisible particle of a substance is atom. So 1 AMU, atomic measurement unit. Now, proton carries no electrical charge and has their mass same as hydrogen. The mass is same as hydrogen and proton has no electrical charge. Now, what is atomic mass? Now, we have seen atom has 3 particles, subatomic particles, atomic mass. Mass of hydrogen atom is considered to be 1 AMU. Mass of hydrogen atom is considered to be 1 AMU. Atomic mass of hydrogen is considered as a standard against which mass of other atoms are measured. So atomic mass is the mass of other atoms in terms of mass of one atom of hydrogen. Mass of other elements, atoms of other elements in terms of mass of hydrogen atom is called atomic mass. What is mass of hydrogen atom? 1 AMU. Now we know that atom has 3 subatomic particles, electron, neutron, proton. What is nucleus? Nucleus is the protons and neutrons make up the nucleus. Protons and neutrons make up the nucleus of an atom. That is the main mass of the atom. Why electron is not considered as main of mass of atom? Because it is 1 by 1840 of an hydrogen atom. Electrons revolve around the nucleus in their orbits. They are called shells. Electrons revolve around the nucleus in their orbit called shells. This shell is named as KLMNOP. It starts with K, KLMN. First shell is K, second shell is L. Now, so the nucleus has positive charge due to proton and it is cancelled by the negative charge neutron, electron, and so atom is overall neutral, neither positive nor negative. Now, if they lose a proton, it will become excess negative. If they lose an electron, they will become excess positive. So that is how atoms gain the charge, by losing or gaining proton or electron. What is atomic number? Atomic number is a number of protons in an atom. So we know there are protons, electrons and neutrons in an atom, but the protons, electrons and neutrons need not be same for all atoms at all the time. So the number of protons in an atom in a normal state is called atomic number. It is fixed for an element. So number of protons in an atom is fixed for an element, but doesn't mean it will remain always like that. By means of a chemical reaction, the number of protons can undergo a change. Now what is Z? Z is a proton number. The number of protons in an element is called the proton number or atomic number, number of protons element. In a normal state, this is fixed for an element. Now, we have seen what is atomic number or proton number. What is mass number? Since electrons are almost weightless, nucleus constitute only the mass of the atom. What is nucleus? Proton plus neutron. Proton plus neutron. Proton number is Z. We know that is the atomic number. So, mass number is A. The number of protons plus neutrons is called mass number. Number of proton is atomic number. Number of protons is atomic number. It is fixed for an element. Number of protons plus neutrons is called mass number. It is again fixed for an element. Number of protons and number of protons plus neutrons is called the mass number. It is represented by A. So A minus Z. Z is number of proton. A is proton plus neutron. So the net will give neutrons is A minus Z. Neutrons is A minus Z. Proton is Z. Proton plus neutron is A. So proton plus neutron minus proton is nothing but neutron. That is A minus Z. Now what is nuclide symbol? The atomic number is shown as a left subscript to the left of the symbol. Atomic number is shown on the left hand side bottom, left subscript to the left of the symbol of the element. Symbol of the element is what? C for carbon, H for hydrogen. Mass number is shown as a superscript on the left, to the left of the element. So mass number is superscript, atomic number is subscript. So this is how we write. When we write like this, the subscript and superscript on an element on the left side, then it is called nucleide number. So 12 above, 6 below, and you write C. That means 12 is the mass number, 6 is atomic number. Atomic number is what? Number of protons, proton number. 12 mass number is what? Proton plus neutron. So proton plus neutron is 12. Proton alone is 6. So neutron will also be 6. The atomic number of carbon is 6 and mass number is 12. So we write as 1262. Okay, now what are shells? As we discussed earlier, the electrons remain inside the atom in the form of, in their orbit. The orbits are KLMN. The number of electron in each orbit or shell is a set rule, follows a set rule, 2, 8, 16 like that. So if there are 2 electrons, there will be only K. If there are 10 electrons, there will be only L. If there are more than 10 electrons, only then you will have M, or else you will not have shell M. It is like that. Now going back to nucleide symbol, this is our nucleide symbol 33Ca9. So 33 on the mass number and this is the atomic number. So on the left hand side top we write the mass number 35, bottom we write the, what do you call, atomic number. So this is how, this is a periodic table. Potassium K, calcium Ca, argon, chlorine, sulfur. So this is how we write, right? Then 35 on the top, 17 on the bottom. Cl means what? 35 is the mass number, 17 is the atomic number. Number of electrons Z equals to 17. Number of protons Z equals to 17. Number of neutrons is mass number minus proton. Mass number is 35. 35 minus 17 is 18. So there will be 18 neutrons. Now 18 neutron will sit inside the nucleus. 17 proton will also sit inside the nucleus. Now the electron, 17 electron has to sit outside. This electron will sit outside how? The first shell K, there will be 2. In the next shell you can see here 3, 4, 5, 6, 7, 8. There are 8 in the next shell K, L, M. Third shell. So 8 plus 2, 10 is gone. We have remaining 7. 7 will be in the third cell. 1, 2, 3, 4, 5, 6, 7. Now, if for some reason an electron is gained, that gained electron will sit in the outer shell. If there is one more electron, then it will be still in the outer shell. One more shell will be there, K, L, M, N. So that is how the shells go up. This is how the nuclear subatomic particle shells in the orbit is shown. This is how the nucleide number is shown. This is on the periodic table. We have calcium, potassium, argon, chlorine, sulfur, etc. Right. Now, what is isotope? Now, as we have seen, atoms are having equal number of protons and electrons normally. If the number of protons or electrons are changed for some reason by a chemical reaction, it becomes positively or negatively charged. It will not be neutral anymore. So, we will see that. Some elements have a different mass number. Some atoms are called isotopes. What is a different mass number? This is 35 is a mass number. So when the mass number changes for some reason, there will be two types of chlorine, for example. One will be with a 35, one will be with a 36. If that is the case, then it is called isotope. Chlorine has two types of atoms with mass number 35 and 37. What other things we have seen like two types? We have seen valencies of two types. We have seen valency, iron has valency 2,3, copper has valency 1,2. This is what? This is the combining capacity of iron with number of hydrogen atoms is the valency. Likewise, we have certain elements which have different mass number, atoms with two types of mass numbers. Atoms with two types of mass numbers. So what happens? 35 and 37. For hydrogen has 1, 2, 3. Chlorine has 35, 37. Hydrogen has 1, 2, 3. Carbon has 12, 13, 14 as the mass number. Only the number of neutron in their nucleus differs. Only the number of electron in the nucleus. This is what? This is electron. This is proton and neutron. So when this mass number becomes increases, the number of proton will remain same because proton and electron has to remain same if the atom has to be neutral. So neutron only will keep on increasing. Neutron will keep on increasing. The number of neutron in the nuclei differs. Number of electron in the nuclei differs. Carbon has 6 electron, 6 proton, and then what is it? Is it 6 neutron or 7 neutron or 8 neutron? Will decide whether mass number is 12 or 13 or 14. What is mass number? Proton plus neutron is mass number. Isotopes have lots of application. For example, there is something called uranium-235. This is used for nuclear energy generation. On the negative side, uranium can be enriched. That is, this isotope can be manipulated, modified, and then it can be used for making atomic bombs, nuclear bombs also. What is ion? Usually atom is electrically neutral, you know, because why? The number of electrons and number of protons are same. But then sometimes an electron can be gained or lost. When an electron is lost, atom becomes positively charged. Why? Because the protons will be more than electron. So it is positively charged. And when electron is gained, more electrons will be there. It will become negatively charged. Na becomes Na plus or Na minus. Na plus or Na minus. What is Na? Sodium. Such electrically charged atoms are called ions. What is ion? Electrically charged atoms are called ions. Now metals lose electron. When you lose electron, what happens? Your electrons will become less, protons will become more. That means what? You will become positively charged. That means what? It will be called cation. When electrons are lost and it becomes positively charged, it is called cation. When electrons are lost and when the atom become positively charged, it is called cation. Now when electrons are gained, it becomes negatively charged, it is called anion. It is called anion. So this is what? Anion and cations. Anions and cations. Now what is anion, what is cation is a question that you need to know the answer for. When metals lose electrons, it becomes positively charged, it is called cation. When non-metals gain electrons, it becomes negatively charged, it is called anion. The number of positive charge of the cation is the same as the number of electrons lost. The number of negative charge of an anion is the same as the number of electrons gained. Now, how many electrons can be gained or lost is limited. You cannot have 100 electrons gained or 100 electrons lost. You can have only 3 electrons that can be lost or gained. Okay. Now let us look at chemical bonding, how the bonding happens. Now how two atoms or elements bond. An electron is lost if and only if there is another atom to take up that electron. You cannot just throw the electron in the dustbin. There should be another element, another atom which is willing to take that electron. An electron is lost if and only if there is another atom to take up. If and only if is very important, or else the cation anion will not happen. Electron lost by sodium, electron is lost, so it becomes Na plus, is taken up by chloride. Chloride has already become Cl minus to form sodium chloride, NaCl. electron lost by sodium is taken up by chlorine to form sodium chloride. Once this forms, the sodium chloride becomes a bond. Now, if you have to separate the sodium and chloride from the sodium chloride, it is very difficult because again you have to rearrange the lost sodium and the gained lost electron and the gained electron to separate it. The force that brings together the positive sodium and the negatively charged chlorine is a chemical bond. Now, how good is the bond will decide on how close together they will ever remain, sodium and chlorine as a compound. The bond formed by transfer of electron is ionic bond or electrovalent bond. Because an electron is lost, it has become positively charged. Because an electron is gained, it has become negatively charged. That means a cation and anion is formed. That means it has become an ion. So the bond between two ions is called electrovalent bond. Electrovalent bond. Result of the chemical bond is formation of a compound. What is a compound that is formed? NaCl. What is NaCl? Common salt. Sodium chloride, common salt. Bonding occurs only when positive and negative charges are balanced. Now it is plus 1 and minus 1 only, then it will become form a bond. If it is plus 2 or minus 1, it cannot form a bond. Bonding occurs only when positive and negative charges are bound. Hydrogen has 1, 2, 3, carbon has 12, 13, 4 as mass numbers, we have already seen. So the bonding will change. For example, sodium transfer of 1 electron to chlorine. This sodium also transfers 1 electron to oxygen. Then it will become O2. It gains 2. Na. So what will happen? Attraction will happen because it has 2 electrons plus. This has one electron loss. So one proton positive. It's a double positive. This is double negative. This can combine together to form a compound. What is radical? Positive ions are called positive radicals. For example, Na plus, K plus, etc. Likewise, negative ions are called negative radicals. O minus 2, S minus 2, etc. Right? Negative radical and positive radical. Some groups of atom behave like a single atom. We have seen helium and all is a group plus it is a single atom. But sometimes more than one atom. H2 is a group of two hydrogen atoms, right? Like that, groups of atom behave like a single atom. Their valency remain intact. Valency means what? Capacity to combine with other elements. Measured with what? Measured with the number of hydrogen atoms it combines to. Their valency remain intact. That is monovalent, divalent, trivalent, etc. They are called compound radicals. When they are more than one in number, together they exist. But their valency remain intact and behave like an atom. They are called compound radicals. Now, some of the chemical formulas are sodium chloride is NaCl, copper oxide is CuO, calcium nitride is Ca3N2, zinc oxide is ZNO, ferric sulfide is FeS, lead sulfate is PbSO4, potassium nitrate is KNO3. So these are some of the formulas for some of the compounds. Now what is the ion? Ion is sodium is an ion, copper is an ion, calcium is an ion. These are all ions. Now these ions are basic in nature. There are some acidic ions, acidic capability. We will see in another class water acids and bases. Chlorine is acidic and this is positively charged, this is negatively charged, and anions and cations. So this is how the ions are formed, and these ions together form this compound, and this is the formula for the compound. Pb is lead, bromine is Br. Lead and bromine, when it is 2 plus, it combines like this, 2 Br and 1 lead becomes lead bromide. Now we have seen what are compounds obtained from living organism or natural minerals. Compounds can be obtained from living organism or natural minerals obtained from causing chemical reaction. Water is natural. So water is a natural compound. Sometimes it is caused by chemical reaction. Sodium chloride we can form by having a sodium and chlorine lose one electron each. What is organic compound? Obtained from living organism like sucrose of the cane sugar or salt from the ocean. Now when you get salt from the rock, you call it as sometimes not organic, not from the living organism. Most are carbon compounds. Most of the organic are carbon compounds. So have C in their formula. What is inorganic? Obtained from minerals like rock salt. This is a different salt, this is a different salt, rock salt. Most are non-carbon compounds. Inorganic are non-carbon compounds. Now there is an exception. Exception is what? Carbon oxide, carbonate, hydrocarbon are considered inorganic. This is exception. Though there is a carbon, they are considered inorganic. Organic compounds are those that contain carbon. Carbon oxide, carbonate, hydrocarbon are considered inorganic, while other carbon compounds are considered organic. What are lab compounds obtained from carbon and one or more elements like hydrogen, oxygen, nitrogen, sulfide? These are called laboratory compounds created in the lab, made in the lab. Hydrogen, oxygen, nitrogen, sulfur combining with carbon are called lab compounds. So this is about the different elements and compounds. Thanks for watching this video. Please keep coming back for more such sessions on science and social studies.